So let us see some other things which we discussed when we talked about the distributed consensus protocol, okay, in the Bitcoin. You just recall that FLP impossibility, the observation which is placed. So what is that impassibility? If you recall that, the difference between synchronous networks and asynchronous network is one. So in synchronous network, every node will receive the transactions which are generated within a given time period. So in synchronous network, every node gets sure that they will get the updated messages within a predefined time threshold. But in asynchronous node, because of the network delay or because of the bandwidth, okay, so every node cannot guarantee that they will get all the messages which are broadcasted in the network. And another condition is, another impossibility here is in this network, because of the external problem or because of the internal problem of any node. Here, node means a computer, a desktop which is connected to the network. Okay, those nodes may get stopped responding to certain messages, right? So that we called the node is crashed or disconnected from the network. And another one is the link fault or the network fault. We say if a link fails to discover the message about the existing nodes, that is another problem. There may be the link failure. Okay, first one is the node may crash. Second one is the link may be disconnected. And third failure in the network is any active node, they may become dishonest. They may become the malicious node. They start behaving like maliciously. So these are another challenging issues. Okay, it may be the synchronous network or asynchronous network, but these are three important points which can cause this network dishonest, or the nodes can be behave like a malicious nodes. So the impossibility theorem which we discussed is the consensus is not possible in a perfect asynchronous network, even with a single crash or single failure in the network. So that can't ensure safety and liveness simultaneously, safety and liveness of a node, which is maintaining the public ledger or the block. Isn't it? So in that case, how to get the consensus then? When these are the cases which are present in the network. So here, liveness is more important than the safety. Liveness means it maintains a block with all the valid transactions. So that's the liveness which we discussed, right? So the Nakamoto consensus, that is the proof of work which we discussed in the distributed network with distributed consensus. The liveness is more important than the safety. So that means the immediate focus is on liveness with a minimum safety guarantee. That is, full safety will be ensured eventually in proof of work. So if you breaking this safety and liveness, if we get into that, suppose if there are 3 blocks and assume that there are 3 miners. So in this, if we recall this, the transactions which are built from these networks. So assume there are 3 nodes which are acting as a miner, and to perform this proof of work. That means to create a new block. Okay. So in that case, every miner, they try to first think what is the basic, the mining process that these miners will take. So what are the tasks of these miners? Okay, so we'll try to understand that first, the task. So the task of this miner is, let's see, to be a Bitcoin miner, every node have to join the Bitcoin network first and connect to other nodes. Once you are connected, there are 6 tasks to perform as a miner. First, listen for transactions. Okay, every node, they first listen for transactions. Okay, so let's say these are the transactions. So first you listen for transactions on the network and validate them by checking that signatures are correct and that the output being spent that haven't been spent before. That is the first task. Second one is maintain the blockchain and listen for a new block. Every miner, they maintain this blockchain and listen for a new block. That means you must maintain the blockchain. You start by asking other nodes to give you all of the historical blocks that are already part of the blockchain before you joined the network. So you then listen for new blocks that are being broadcasted to the network. And you must validate each block that you receive. So by validating each transaction in the block and checking that the block contains a valid nonce. So then, we'll return to the details of this nonce. Okay. But the third step is assemble a candidate block. Okay. By collecting all the transactions and then arranging these, the transactions in their block, that assemble a candidate block means once you have a up-to-date copy of the blockchain, you can begin building your own block. And to do this, you will group the transactions that you heard about into a new block that extends the latest block you know about. So you must make sure that each transaction included in your block is valid. All the transactions like miner 1, miner 2, or miner 3. Then the next step is it needs to find the nonce. That is the difficulty, needs to compute the difficulty. So find a nonce that makes your block valid. So that we have discussed the target. Okay. So this step requires the most work, and it's where all the real difficulty happens for miners. And once you're just hoping that your block which is created will be accepted. So even if you find a block, okay, so in safety, what is happening? The next block should be correct. That is safety. Liveness is that block is up to date. So the transactions which are verified and the block contains the correct hash and nuns. So this can be ensured the block mined by a miner is verified by all the miners in the network. So then that will be all the miners should agree on a single block, and the next block of the blockchain should be selected, and the miners do not know each other. So how can they agree on the same block? Okay, there may be some compromise here, right? So the liveness that add a block as long as it is correct. That means it contains valid transactions from the unconfirmed transaction list, and then move further. So hope your block is accepted. Even if you find a block, there is no guarantee that your block will become part of the consensus chain. So there is a bit of luck here. You have to hope that other miners accept your block and start mining on top of it instead of some competitor's block. And finally, if the liveliness, two different miners may add two different blocks. Okay, that's a possibility. So that will resolve this later. Okay, so once these transactions are broadcasted, there is no fixed ordering of the transaction in this blocks, and no fixed number of transactions per block, and there is a limit on block size in the Nakamoto consensus proof of work, isn't it? So then they generate the proof that is nuns. So this is the complex task, and then done the verification easily, and the expectation is one of the miner will be able to generate the proof of work. Okay, so then if that block is accepted by every other miners, then the miner must get a profit. If all other miners do accept your block, then you profit. At the time of this, when we are talking about this discussion, the block reward is around 25 bitcoins or 30 bitcoins. That depends upon their worth. Okay, so we can classify the steps that a miner must take into two categories. Some tasks are validating transaction and blocks that help the Bitcoin network and are fundamental to its existence. Okay, one is validating transactions and the blocks. Right? So once it is selected, then the miner signs the block and broadcasts it and use the gossip protocol in the peer-to-peer network, and this block will be added to the blockchain technology, blockchain. So then it removes the transactions. When this block is added, the miners, if they are having these transactions which are already added, then those transactions will be removed, okay? Like 22, 17, 16, 31, 49, those transactions will be removed from their blocks to make sure that there will not be any duplicate transactions from this unconfirmed transaction list. Okay. So here, in reality, more than one miners, they generate the proof of work, means they generate the block. When these miners, when they broadcast these blocks at the same time, okay, and which one is going to be added? Which block will be added? Okay. So when the two different miners, they have these blocks ready to join. So in this case, one way to fork the software and the rule is to start a new blockchain with a new Genesis block. So this is a popular option. This the fork rule is the popular option for creating altcoin. Okay, but for now, let's consider a different type of fork in the rule, one in which those who fork decided to fork the blockchain as well. So if you recall the distinction between a hard fork and a soft fork, okay, so we are talking about the hard fork here at the point when there is a disagreement about the rule, there will be a fork in the blockchain. So resulting in two branches. Okay, resulting in two branches. So by adding this, so the consensus finally is not ensured. So safety is not satisfied immediately here. So the network remained partitioned for some amount of time. So that momentary decision is the miners remove the transactions corresponding to both the blocks from their unconfirmed transaction list. So these forks are resolved eventually for the next block creation. A miner accepts the previous block that it hears from the majority of the neighbors. From the majority of the neighbors. So eventually, one block becomes the part of the main blockchain. Okay. So that is the key concept. So for a forked block, if the transactions are not yet committed, that means include them in the unconfirmed list. So one branch is valid under rule set, but that is invalid under a rule set B for another transaction. So once the miner operating under these two rules that set separate, they can't come back together because each branch will contain transactions or blocks that are invalid according to other rules. So we can think of this currency, okay? So the interesting case is if the fork reflected a fight between two groups about what the future Bitcoin should be. In other words, a rebelling within the Bitcoin community where a subgroup decides to break off or decides they have a better idea about how the system should be run. So you can see this, the new transactions, okay? So in this case, the fork block, if the transactions are not yet committed means if they are not yet added, okay? So in this, if you look at transaction 16, 17, 31. So 16, 17, 31 is added, okay? But 87 is not added. So that is a unconfirmed transaction that can be added into their blocks. The miners, they add that transaction into their block, right? So eventually, the consensus finality in Bitcoin that cannot use a transaction until confirmation of 6 blocks, until confirmation of 6 blocks, which are 6 miners, which are ensured through the script, which we discussed, the Bitcoin script. Okay. So this is all about the consensus, that is proof of work. We call this as proof of work.